And we're back for part 4 of the Stoichiometry Review Guide. We are looking at percent composition on pages 7 and 8. So the thing to remember about percent composition is that, hold on, let me turn on a pen here. Percent for us is going to be part over whole times 100. And for this particular kind of problem, the mass of each element is going to be our part. So basically, what part is carbon, or what part of the compound is sodium? And then the whole will be the mass of the whole compound, so the molar mass of the whole thing all added up. Times 100 to turn it into a percent, and that's all we have to do. So let's look at sodium chloride. We're going to find percent composition of sodium chloride. The first thing that we have to do is write a formula for sodium chloride. Sodium has a charge of +1, chloride has a charge of -1. So happily, these balance each other right out. To find the percent that is sodium, I'm going to find the mass of sodium on the periodic table. It's 22.990. Divided by the whole mass. So I need to take these two and add them together. Sodium is that 22.990 we were just looking at, and chlorine is 35.453. We add those together and get 58.443 grams. So this is our whole, 58.443. And then to turn this part divided by whole into a percent, we multiply by 100. And if I turn my calculator back on, we get 22.990 divided by 58.443 times 100 to turn it into a percent. And it's 39 I like to keep a tenths place when I'm doing percents. So 39.3% sodium. We'll do the same thing for chlorine. So chlorine, we have just the 1. It's going to be that 35.453. 35.453 divided by same whole, because we're talking about the same whole compound, 58.443 times 100. Do that division times 100, and we should get 60.7% chlorine. One way to check to make sure that you have done your math correctly is to add your percents together. They should all add up to 100%. And ours does, so we can be fairly confident that we did something right. Let's look at number 2. Percent composition of carbon in glucose. So I'm worried for this one only about the carbon. I don't need to worry about hydrogen or oxygen in this particular question. So step 1 is to figure out how much carbon we have. I do need to add all the carbon, all 6. So I'm going to do 6 times the mass of carbon on the periodic table is 12.011 divided by everything added up together. 6 carbons, 12 hydrogens, 6 oxygens. So 6 times 15.999 plus 12 times 1.008 plus 6 times 12.001. And that turns out to be 180.156. Whoa, 6, not 9. 180.156 times 100 to make it a percent, and that turns into just about 40% carbon. Let's look at the percent composition of lead-4 phosphate. A lot of pieces and parts. So step 1, I need to write a formula for this. Lead-4 has a charge of 4. That's what the Roman numeral tells us. Phosphate is a polyatomic ion, PO4, with a charge of +3. Whoopsie, -3. Sorry, that's a minus, not a plus, -3. So I look at my +4 and my -3, and those do not match. I need to think about how to scale those up so that they do match. My least common multiple of 4 and 3 is 12. So I'm going to take 3 of these and 4 of these. 3 times positive 4 is 12. 4 times negative 3 is negative 12. Those balance each other out. So I need 3 leads. 4 times 1 is going to be 4 phosphoruses. And then 4 times 4, I need 16 oxygens. So lead times 3 is going to give us 621.6 grams. 4 times phosphorus is going to give us 123.896. And 16 times oxygen is 255.984. Add all those 3 pieces up, and our whole mass is 1,001.48. And we'll use that whole for each of the elements. Times 100 each time to turn it into a percent. And what do we get? 62.1% lead, 12.4% phosphorus, 25.5% oxygen. And if we add those all up, magically 100. Easy peasy percent composition.